Good evening, everybody. Today we are going to discuss this Jones chopper and AC chopper as well as oscillation chopper. For all these things, the basic thing is here class D commutation. Right here in this class D commutation, so you know that two thyristors, one is main thyristor and one is auxiliary thyristor is used, and this L and C acts as a both commutating element. Okay, so and here the load is RL load I have considered and a freewheeling diode is used. These are the waveforms. So of course, this class D commutation I already discussed in your classroom, but again I will discuss because class D commutation is same as that of same concept will be presented in Jones chopper as well as oscillation chopper also. For slight modification, I will tell you what is that slight modification. But first of all, I want to again discuss this again this class D commutation once. Okay. So first in the mode one operation, right? So at t is equal to 0, right? I have switched on this thyristor Tm, right? So and here we have to assume one thing. What is this? Initially, what is the capacitor voltage is nothing but Vs. The source voltage, this magnitude is nothing but Vs. Capacitor voltage is Vs. We have to assume like that. So once you switch on this one, right? So there are two currents. One current is from source to load, right? Through Tm. Another one is the capacitor current through Tm and diode and to the this inductor and return path, right? So now here, how many currents are flowing to into the thyristor, main thyristor? Two currents. One is IC current, another one is load current. This one, right? So therefore, if you observe, this is the thyristor ITM current, two currents, right? So therefore, this one what happens is sinusoidal. Why you are getting sinusoidal? See, this is IC current, sinusoidal current, because this current is flowing through your L and C. Whenever you are having L and C combination, right, you are getting a sinusoidal wave. Okay, right. So this is only about your capacitor current waveform. But because of this in thyristor Tm, two currents are flowing. One is this load current, another one is this capacitor. So because of both currents, what happens here? This I naught plus Vs into root C by L. So this part is I naught. If you take this line here, this is I naught. So I naught plus Vs into root C by L. What is Vs into root C by L is maximum capacitor current. Maximum capacitor current. So at this point, what happens here? I naught plus Vs into root C by L. See this Vs into root C by L, how we are getting means you just refer class B commutation. I already derived in your notes, so you just check it once, right? So this will be happened right up to this point, which is nothing but pi root LC, right? So next, coming to the capacitor voltage. So initially, what is the capacitor voltage? These are the polarities. Now, because of switch on this one, the current is flowing like this. At the end of this mode, what is the polarities? Negative. So that means slowly the capacitor charges to a reverse polarity. So that means you will get like this. Okay, right. Next, here, you know that for inductor as well as capacitor and coming to the current, if you take the relation between voltage and current in either in capacitor or in inductor 90 degrees phase shift. So here see when it is 0 we are having maximum voltage, when it is maximum here 0 voltage, again when it is 0 here. So here because it is a voltage is Vs, but what happens is reverse polarity. Okay, right. So coming to the V naught, what happens? A load current, constant load current will be circulating like this. So because of I naught, what happens is I naught is equal to V naught into V naught is equal to I naught into R, the constant voltage. So see this load voltage V naught, the load voltage V naught, right? So is directly connected, parallelly connected to your source voltage Vs. So that's why this magnitude is Vs. Okay, right. This is about your mode one operation. Now at the end of this mode, if you observe these polarities, see this negative is applied to anode, this positive is applied to cathode. Okay, so that means a reverse voltage will be existed here, but what happens is the ACR still it is in on state, right? Because I didn't given getting pulse to this one. So once I will give the gating pulse to this one, then only the current flows from this plus Vc auxiliary thyristor a reverse current will flow to this TM and to the return path. So this will be happen within a very short time only. Understand what I'm saying? So because of these two means this capacitor will go to dead short circuit, right, within a short time, right. So a high rise of current will flows in this fashion, and also a reverse voltage. This negative is applied to anode here, and positive is applied to cathode here. Because of reverse voltage, it will goes to turn off, right. So now we'll see that one. See here, actually the first mode of operation will be completed here only. See here, I'm not doing any operation. This is constant, and this is zero, and this is also constant. So, but where I'm doing the operation M2 means at this point. Okay. So at this point, I will give the triggering pulse to thyristor TA. That will be discussed in the next slide. So at this instant mode to starting, right, I will give the triggering pulse to thyristor TA. Therefore, how the current flows? Plus Vs, this capacitor, TA, and load RL load, and to the return. Understand what I'm saying? So now here, see how these two voltage sources are in aiding position, right? So this is minus Vs, this is minus Vc. Of course, magnitude is Vs only. So minus Vs and minus Vs, what happens? You will get 2 Vs. So that's why the magnitude is 2 Vs. Just apply the KVL, simple KVL, minus Vs, and again minus Vs, because capacitor voltage is equal to Vs, minus Vs, and to the load. Here V0, you can assume V0. So V0 plus V0 and 0. So therefore, V0 is equal to, will get immediately 2 Vs, right? So whenever the current is flowing like this, right, path, like this path, right? So slowly the current is flowing in this direction, right? So see, actually the current reference current direction is this one. Now the current is flowing in this direction. What is this current? This current is flowing through the load. So that means what happens? This capacitor current is equal to your load current, which is a constant one. But here I am plotting with the for the capacitor waveform, right? So see, this is actually current reference current direction. But how the current flows in the opposite direction? So that's why I am getting a constant one. Why constant one means the load current we are assuming it is a constant one. Here a constant current only will flows to the device. Okay, right. So now after some time, what happens is the capacitor voltage will reaches to a positive voltage like this. See this one, capacitor voltage will reach this one. Understand what I'm saying? And coming to this waveform, see at the instant of mode 2, what I said, when I give the triggering pulse to this one, a sharp rise in current will flows, and immediately what happens is SCR will turn off, right? So because of that reason, your TM will be off. Therefore, the current flowing through TM is 0, right? So, and at the end of this mode, what is the polarity here? Positive polarity. So that means this one. So at that time, this is plus Vs, this is also plus Vs. Both are cancelled each other. Therefore, your output voltage will reach us to a voltage of 0. Understand? Right. So next mode of operation, mode 3 in this case, right? So, uh, so at the end of this mode 2 operation, what is the polarity here? The polarity is plus and minus, right? Because of plus and minus, right? So here negative voltage is applied to anode, positive voltage is applied to cathode. Therefore, this TA will be turned off. So here TA is also going to be turned off, right? Understand what I am saying? So why TA is turned off here? Whatever the current means, see, this is voltage Vs, this is also Vs. Whenever both potentials are same potentials, then what is the current here is automatically 0. Therefore, to turn off your SCR, two conditions must be satisfied. First one is current reaches to 0. Second one is voltage reverse voltage. So because of both opposite potential, the current is 0. So that's why here the current will goes to 0. Current is going to 0. And immediately what happens? Because of reverse polarity, this reverse polarity is applied here. Therefore, it will be off state, right? It is going to be off state. Next, again, this positive is applied to main thyristor anode, negative is applied to main thyristor cathode, right? So therefore, it will become forward bias, but I am not giving the gating signal. That will be presented in the next cycle. Next cycle, if you are doing it, right? So for this, right? So already I have discussed each and every formula in your notes. You just go through your notes, right? And what is this ECM? Circuit turn off time of main thyristor. Okay, circuit turn off time of main thyristor. So what is circuit turn off time means? the SCR is reverse biased by a commutation circuit, right? So for this thyristor, where is the reverse bias? This is the reverse bias because current is reached zero, and again your reverse voltage is also zero. That's why it is the circuit turn off time for TCM. Next, see this part is also TCM, therefore total this part is 2 TCM. Next, coming to whenever after mode 3 operation, whenever you will switch on this thyristor TM, right? Then again what happens? The same, this will be repeated, right? For example, if you start here means the current the voltage will be reduced slightly. The same will be I have repeated here. I will previous cycle. So again, what is the circuit turn off time for auxiliary thyristor is this one, because the current reaches zero and reverse voltage is also reached zero here, right? So because here current is negative, voltage is positive. That means opposite. See here, first one for the thyristor, main thyristor, here the current is positive, whatever the voltage negative. So for this auxiliary thyristor, this means TA, right? Auxiliary thyristor, this current is negative means voltage is definitely it should be positive, right? Because it is opposite. Okay, right? So here whenever you switch on the your main thyristor here, right, the voltage slowly reduces. So what is the circuit turn off time? Where your current reaches to zero and again SCR voltage also reaches to zero. So current reaches zero, again your voltage reaches zero means this point somewhere next cycle. But that next cycle is I have shown here. So this is your TCA, which is equal to pi by 2 root x. Okay. So this is your class D commutation. Already I have discussed in your class itself. Again, I have repeated because of Jones-Chopper, right? So now see what is the difference between Jones-Chopper and class D chopper. Both almost 99% are same. Only the difference I will tell you. See, first of all, you just observe this one commutation circuit. So TM, TA, diode, inductor, capacitor. This commutation circuit, this one both are same. Again, the load here also it will be same, right? Here also it will be. Understand what I'm saying? Freewheeling load, everything is same. But here one inductor is there, but here what happened? Two inductors. In some cases, we are calling it as a coupled inductor, right? So that means based upon coupling means what happens based upon the current flowing here, some volt because of some flux, what happens? A voltage, high voltage will be induced. That high voltage will be is required to turn off your main thyristor. Compared to this one, if the voltage across capacitor is high, then it is easy to turn off. That's it. That is only the difference. Remaining everything is same. Okay. So once I want to go back, see here in first mode 1 and in mode 2, what happens is the inductor is energizing. The polarities of inductor is plus and minus. In mode 3 operation, because of these two switches are off, then what happens? The polarity of inductor is reversed. Then the current flowing is in this part. Okay. So that because we are assuming constant current. The same thing will be happen for Jones-Chopper. Just only the difference is we are taking L2, that is coupled inductor, to boost the value of the capacitor voltage. That's it. And this the one more advantage of keeping this L2 is to smoothen your load current, right? Because because these two are connected in series. This L2 load inductor are connected in series. Because of these two, what happens? The load inductance will be total inductance will be increased. Therefore, the load current will be almost constant. So that is the one more advantage you can say, right? So whatever operation I have discussed for class D chopper, you please write down for the Jones chopper, same thing, no change. Even one point also not a change. Okay, so that is the thing. Only just add this L2. Understand what I mean? So this is about your Jones chopper. Please draw the same waveform, same explanation, no change anywhere, right? Except this thing. Okay. Next, coming to the oscillation chopper, right? Again, if you observe, see this part and this part, again it will be same. Then what is the difference? Means this one. So actually here initially the capacity is charged by using this switch, and remaining operation everything is same. So first in case of 1 second. So in case of class D commutation, starting itself I said that assume this capacitor is charged with a voltage of Vs. This part is Vs. Understand what I am saying? So now the same concept. Here we are assuming all capacitor. I mean the capacitor is already charged, right? In the class D chopper, we have taken assumption. Whereas coming to the oscillation chopper, we are charging the capacitor with the help of the switch. So now when the switch is closed, what happens? The current is flowing like this, and firstly initially voltage is 0, and at the end of this mode, what happens? The capacitor is charged with a voltage of Vs, right? Then again, what happens? You just start the operation from here, the same operation, mode 1, mode 2, mode 3, everything will be, right? So this is your oscillation chopper. Just this mode only you can write. Remaining everything in remains. Okay. So again, once it is charged to the Vs, you just go to the class D first mode of operation and you can proceed. Okay. So next, coming to AC chopper. What is meant by AC chopper means it converts fixed AC voltage to variable AC voltage, almost equivalent to your AC voltage controller. But AC voltage controller will obtain natural commutation, but here we are using what happens? Forced commutation. In case of AC voltage controller, what happens? The output voltage is presented up to first half cycle end, that is pi, and second half cycle ending point 2 pi, right? But here in AC chopper, the output voltage is presented in between the half cycle of the waveform, right? I will show you later. So that is the difference. But nobody will use nowadays this one because of AC voltage controller requires only 2 ACRs. But here, how many ACRs are required? 4 ACRs and commutation circuit. That is a disadvantage, right? So first, initially, assume during positive off cycle, then all ACRs are in off state because I am not giving any gating pulse. So it is a forward bias. Some devices are forward bias, but I am not giving any gating pulse. So though all ACRs are in off state, therefore the current will flow in this fashion. The current cannot flow in this direction because the diode is reverse biased here. So the total current will flow like this. Okay, right. So then the capacitor is charged. So once the capacitor is charged like this, right? So this capacitor is charged with the voltage of some Vs, some constant voltage of Vs, right? So this is about in positive half cycle. In the negative half cycle, what happens? The capacitor will charge like this, C1. C1 capacitor will be charged like this. So initially, to start your operation, your capacitor must be charged with a voltage of some magnitude Vs. Okay. So these two capacitors are required to turn off your main thyristors T1 and T3. Sorry, T1 and T2. T1 and T2 are main thyristors. T3 and T4 are auxiliary thyristors. T1 here T3 is used to turn off your thyristor T1. Here T4 is used to turn off your thyristor T2. Okay, right. Now, so next one here, yeah, this one. This is the input voltage, so output voltage, and IT1. Just only have taken this thyristor current, and IT3, right, for proper computation how to show. And assume that initially the capacitors are already charged. That is very important. Okay, right. So here I have taken VC1. See, the VC1 is already charged like this. Okay, some voltage it is charged, right? Now, first during positive half cycle at omega T1, right? At omega T1, T1 is forward bias. Then I am giving the triggering positive thyristor T1 because this is phase, this is neutral. So assume this is positive and this is negative. So positive is connected to anode. So obviously here negative. So therefore it is forward bias. Therefore what happens? The current will flows in this fashion to the load, right? So this is generally is happening in AC voltage controller also. Now, see, I have triggered my SCR here, and I want to turn off my SCR here itself. Generally for AC voltage controller, see, this is input voltage is 0 here. Your SCR will be continuing till up to this point. SCR will be continuing continue the conduction up to this point. But whereas in case of this AC chopper, I want to turn off my SCR here itself, right? Then it is possible because of this forced commutation circuit and along with this auxiliary thyristor T3. Okay, so when the thyristor T1 is in on state here, it will be conducting from omega T1 to omega T2 like this, right? Now at this instant omega T2, I want to turn off this thyristor T1, right? So here already input voltage having some magnitude. So to turn off this thyristor, what happens? Two conditions. One is current should be 0, another one is reverse voltage. But here already it is having positive voltage only, so it won't be turned off. Then we have to go for the only other way is forced compression. Then to turn off this thyristor T1, I will trigger this thyristor T3 because here positive is connected to anode. Therefore, obviously here cathode is negative. So once it is turned on, therefore the current will flow through this C1, T3 and opposite direction to T1 and to the return. Understand what I am saying? So that I will show in the next one. Right. See here. So initial value is this one. Once you will give the triggering pulse, the current will flow in this direction, reverse current. Okay, so reverse current will flow, right? So then automatically your T1 will be turned on. Now look at here, at omega T2, I will trigger the thyristor T3. See, sudden rise of current. Now, if you observe the magnitude here, what is the magnitude here? Almost some 20, right? What is the magnitude here? Some 35 around like that. Because I have taken this is from simulation point, simulation. So I want to show clearly. So this magnitude is higher than that of your this magnitude. That means IT3 magnitude is higher than that of your IT1. So that's why the current will be flowing in this fashion because of highest current, this red color one. That means T3 current is higher than that of your T1 current. Automatically this T1 will be turned off, right? So see, once T1 will be turned off, what happens? The output voltage is 0. Understand? Right. So you may ask one question. So of course the T1 will be turned off. There is a chance of current will flow this phase capacitor current T3 and to load and to the return path. Okay, there is a chance. But see, whenever this thyristor is on, this capacitor goes to dead short circuit. This capacitor will goes to a dead short circuit. So within a short time here the current reached to 0, right? This thyristor T3 current is also goes to 0 here itself. Okay, the thyristor T3 current is goes to 0 here itself. So once it is 0 and see the capacitor voltage is changed from positive voltage to negative voltage, right? So because of these two are turned on within a very short time, right? So very short time. Because of that very short time, what happened is this capacitor is charged to a reverse voltage and the current reaches to 0 also, right? Here the current reaches to 0 also. So to turn off your AC, two conditions must be satisfied. One is this what happens, this current reached to 0 and reverse voltage. See, this negative voltage is applied to anode and positive voltage is applied to cathode, therefore it will be turned off. Understand what I am saying? So at this moment, right, because of T3 current is greater than T1 current, your T1 will be turned off. And within a short time, these two are in on state. So because of that short circuit, right, the current will be immediately raised and immediately it will falls to 0 because the capacitor will allow the sudden changes in current. And see here, you may ask one question here. The capacitor will not allow sudden changes in voltage. Okay, so that's why here some time is there, right? So slowly having some time here, right? So because of sudden short circuit, slowly having some slight uh, angle is there here. So in simulation, if you zoom it, you will get that one. Okay, but at this moment, current immediately will rises. So if possible, I will show the simulation later, right? So that's why here voltage is coming negative itself, right? So because of this current 0 and voltage negative, your SCR T3 will be turned on, right? So now see here T1 is turned on, your T1 is turned off as well as T3 is also turned off here itself, right? Because of high voltage spike is coming here because of this current. Because suddenly here current is rises, a spike will come in here. Okay, so that you can neglect in the examination. You need not write this spike, just to represent this one, right? So in case of AC voltage controller, your output voltage will present up to here, AC voltage controller. After this one, what happens is the reverse voltage, so it will be turned off. But here in AC chopper, I want to turn off here, so it is not possible by using natural computation. Definitely forced computation is required. So that's why we are using this T3 and reverse current will flows, and what happens is suddenly voltage will goes to less, I mean changes to negative to positive. Understand what I'm saying? So this is about your AC chopper in the first half cycle. In the second half cycle, that means negative half cycle. During negative half cycle, what happens? This will be positive, neutral will be positive, and this will be negative. So therefore, this positive is connected to this anode. Therefore, obviously, a cathode. Therefore, your T2 will be turned on. So see, this T2 will be turned on. So a negative voltage will be developed. So I have taken here negative half cycle, negative voltage will be developed. Again, I want to turn off here. Then what happens for T2? Which one is this one? T4 we have to turn on. So see here, this for this cathode you have negative voltage, and here positive will be coming. Therefore, it will also turn. Okay. So in this case, so if you observe here, at this instant, what happens is the capacitor uh, will, the capacitor will discharge its energy like this. And I said that this capacitor current is more than that of your load current, then immediately it will be turned on. Right here, T2 will be turned on. Same as that of your 41. Okay. So this is about this one. And again, just one second. So here see, at this instant the capacity is changing from negative to positive, and again it is slowly charging to positive voltage only, right? Because whenever this VC1 means this one, VC1 will goes to positive when you have neutral is positive and this is negative, then only the current will flows like this. Okay, otherwise you just go for previous slide. Yeah, this one. See, negative half cycle. In negative half cycle only, it will be charged like this, right? So, therefore, what I am suggesting here, once it is negative, this voltage slowly goes to negative. So that's why it is slowly charging into the positive value, right? So even you are having negative voltage here, some leakage current will flow through here. So that's why it is charging to a voltage to the positive mode of operation. Whenever you're having negative, definitely it will reach to the positive voltage. Refer the slide, the previous slide, mode to operation of AC chopper. Right? So this is about your AC chopper. The main advantage is only you want to turn off your SCR middle of the positive half cycle, then it is possible in AC chopper, but in AC voltage controller it is not possible. So this is the thing. For the examination point of view, you need not write this capacitor voltage, because you otherwise you just draw, assume this is a constant voltage like this and like this, again it is charging like this, right? Otherwise just write an input voltage, output voltage, and IT1 and IT3, right? So for IT1 and IT3, we just try for what I can say that compared to this current, this IT3 current is more than that of IT1. So that's why reverse current flows to this IT1 and it will be turned. Okay, like that you can explain. Okay, so this is about your fourth unit having some Jones chopper, oscillation chopper, AC chopper. The only thing is Morgan's chopper left. Already I have shared some other videos. We'll just try to watch that videos. If you have any queries, we just ask. Okay, otherwise I will discuss